Good morning or afternoon, everyone. My name is Mariela Salinas, and I'm a marketing specialist here at Educate 360. Welcome to today's webinar, What Programming Language to Learn, presented by our instructor, Jose Portilla. We are using the Zoom platform for today's session, and we will be sharing a copy of this recording with you in an email after the webinar. We do encourage participation throughout the webinar, so please use the chat or our Q&A option for our short Q&A portion after the presentation. Educate 360 is so excited to present this webinar today. I will now hand it over to you, Jose.
Thank you. Good morning or good afternoon, everybody. So in this webinar, we're going to be discussing different programming languages and which one to learn depending on your use cases. So obviously choosing the right programming language is essential for ensuring success and efficiency of any software project. And choosing a programming language can significantly impact things like the development process, the performance of the software, and even things like how easy it is to maintain the actual project itself. And so different programming languages offer unique features and capabilities. For example, if you needed really strong performance and efficient memory, maybe you would choose something like C++ or Rust. Or if you're working a lot with databases, you would use SQL. Or if you're working with mobile programming languages like Swift for iOS or Kotlin for Android, those would be better choices. So what we're going to be doing here is understanding strengths of different languages and the different use cases for them, and which would be appropriate for you to choose depending on your project. So before you even begin before we begin our tour of all the programming languages, we should talk about how you would actually select a programming language. And a big part of this is considering the type of projects you're going to be working on, as well as the potential industries you're interested in. So different industries often have preferred programming languages already based off their specific needs and technical requirements. For example, if you're interested in web development, languages such as JavaScript, HTML, and CSS are commonly used. While in industries like data science and machine learning, those are favorite languages like Python and R due to their robust analytics and statistical capabilities. And additionally, assessing the availability of learning resources and community support for the programming language is crucial. Learning a new language can often be quite challenging, so you want to make sure you have ample resources and training support along with an online community that can hopefully significantly impact your learning experience and possibly career opportunities as well. You're going to want to try to lean towards languages that have extensive documentation, tutorials, and active community forums. And then furthermore, depending on your actual goals of learning a new language, sometimes you want to learn a new language to work on an internal project within your organization, or trying to learn a language to potentially, level up to some other employment opportunity. You want to also evaluate the job market and how it aligns to your career goals. So a couple things to consider when choosing a programming language. We've already mentioned this a little bit, but you're going to want to compare the performance capabilities of different programming languages. So those are things that involve assessing factors like speed, memory usage, and efficiency in handling large data sets. Speed refers to the actual execution time of the code, whereas memory usage pertains to the amount of system memory a language utilizes while running programs. And efficiency, on the other hand, that encompasses the language ability to process and manipulate large data sets without consuming excessive resources. So these performance metrics are pretty critical considerations, particularly for applications that demand real-time processing, computational efficiency, or memory optimization. And in addition to performance, you also just want to evaluate the capability of the language, such as its support for various paradigms. So is it a functional language? Is it object-oriented? Is it suitable for different applications or just narrow-scoped applications, like you mentioned before, web development and data analysis? And then finally, when comparing programming languages, as I mentioned, community support and resources are also a key consideration to make. And then, as I mentioned in the, 2 slides ago, you're going to want to evaluate the job market and opportunities for different programming languages. So just to give you a quick example, Python's widely used in things like data analysis, AI, that could create diverse job opportunities depending on what you're working with. JavaScript, essential for front-end web development. Increasingly popular frameworks like React and Angular require you to learn JavaScript, or things like TypeScript. And then Java still remains as stable in enterprise software development, could provide a strong foundation for career opportunities in large corporate environments that are maybe running legacy software. So with that all being said, just a couple of considerations on selecting a language and how you would choose it. Let's go through kind of a language tour. So I'm not going to basically at the end tell you, oh, just choose this language, it solves all your problems. Again, it really depends on what you're trying to achieve. So in this tour, we're going to go through the major programming languages and figure out which ones work best, depending on your particular use cases. So starting off with a very popular programming language, there is Python. So Python is a widely utilized programming language. It is often used for the back end of web development that offers frameworks such as Django and Flask. And these frameworks empower developers to create powerful and scalable web applications with ease. So Django, for instance, follows what is sometimes known as a batteries included philosophy, in which case they provide a wide array of built-in features. So that could make it an excellent choice for stable, larger developments. Meanwhile, Flask for web development, that's known for its simplicity and flexibility, just quick, simple websites. So you can use Python for the backend of web development. Its versatility, however, extends beyond web development. It's become a really popular choice, the most popular choice for things like data analysis. And this is due to its comprehensive libraries like NumPy, Pandas, and Matplotlib. Libraries are additional packages that are outside the core of the programming language, but still require you to know the programming language in order to use the packages. So for example, NumPy provides support for large multidimensional arrays and matrices for scientific computing tasks. On the other hand, Pandas offers data structures and functions that facilitate the manipulation analysis of structured data, making it an essential tool for data analysis. And then Matplotlib, for example, provides a wide range of visualization capabilities to present data effectively. That makes Python a really ideal choice with this ecosystem of libraries for working with expansive data sets, performing complex data analysis tasks, and then creating visualizations to explain. Now, as we know, AI and machine learning are hot topics today, and Python has also emerged as a leading language in this category. So it also has extensive libraries such as TensorFlow and PyTorch. TensorFlow is a library developed by Google. It's renowned for its flexibility and scalability. It's a popular choice for really large-scale machine learning projects. And PyTorch, which was open sourced and developed by Facebook/Meta, it's known for its ease of use in what are known as dynamic computation graphs. Again, these are more like neural networks and deep learning. And what's nice is all the libraries I mentioned here rely on Python's clean and readable syntax. So it makes it an ideal language choice for developing AI and machine learning applications. So what about Java, a really popular language as well? So Java is a widely used language for developing typically enterprise applications, and this is due to its performance and independence and robustness. So this means that Java applications can basically run on any platform that has what is known as a Java virtual machine or JVM installed. So Java also has what is known as type safety, and it basically helps you create robust applications that try to eliminate errors because it's checking the types of objects you're passing in. It also has lots of exception handling features. And one of the key factors contributing to Java's suitability for enterprise solutions is also its own extensive set of libraries and frameworks. So these are tools such as Spring and Hibernate, popular choices for building scalable and secure applications. These libraries and frameworks hopefully will streamline your development process and enable you as the developer who knows Java to focus on business logic and application functionality rather than low-level technical details. And I should point out, Java is definitely a more mature language, so it already has an established large talent pool of experienced developers and garners support from corporate entities. It is definitely not as popular as Python, in kind of modern day programming. Python is growing much faster, but there's still a big pool of Java developers. So when you're thinking Java, think more of kind of these legacy enterprise applications. So what about C++, another very popular, just general programming language? It's a popular choice for developing system software and applications that need high efficiency and high performance. It basically allows developers to write code that can directly manipulate the memory and hardware. It's sometimes what we call close to the metal programming languages. in that it's operating in a lot more close operating to the, how should I say, it's like the actual CPU on your computer. So basically what it's doing is it's suitable for system programming that requires low-level control over resources, things like device drivers or operating system development, or just any software that interacts closely with hardware. That means robust support for things like multi-threading, which is essential for handling complex and concurrent operations in system programming. And multi-threading allows a simultaneous execution of multiple threads within the same program. So that enables better exploitation of multi-core processors and efficient utilization of system resources. So that capability makes C++ well suited for developing software that needs to handle parallel tasks, such as real-time processing, network communication, and multi-user systems. So with its powerful multi-threading support, C++ provides developers with the flexibility to create efficient and responsive system software and applications. Now, we just some general programming languages like Python, Java, and C++. Let's move into some more specific and narrower programming languages. So Swift is a good example of this because you can't use Swift to make any application. It's actually the primary programming language focused on iOS and macOS app development. So what does that mean? That means if you're learning Swift because you're developing for an Apple product, like an iPhone or a MacBook Pro. It has clean and expressive code, and it allows developers to maintain code more efficiently, reduce the likelihood of errors, and enhancing productivity. Now, that isn't to say you can only use Swift to develop applications for the Mac and the iPhone and that sort of thing. If you wanted to develop a MacBook application, you could have technically used C++ or Java or Python. It's just that Swift was developed internally by Apple specifically to help you write your code once and make it a lot easier to then add a couple of bits and pieces to that code so that it runs on both like an iPad and an iPhone. So you can develop really powerful and efficient apps with Swift. It has tons of libraries and frameworks. It also comes with its own set of standard libraries and community-driven frameworks to provide a wide range of tools for tasks such as things like networking, data management, and user interface development. So this not only streamlines the app development process, but also ensures that developers have access to well-maintained and optimized solutions for common challenges in iOS and macOS app development. So again, the language was developed by Apple, provides a wide range of support for different platforms and devices. And with Swift, developers can build apps not just for iOS or macOS, but technically speaking, also watchOS, tvOS, future Apple products. So Vision OS, if you have heard of the Vision Pro from Apple, that would operate with Swift on the background as well. Other libraries like Reality Kit. And so the versatility there makes Swift a really great strategic choice or really aligned with the Apple ecosystem. So on the other end of this, basically for Android development, you have Kotlin, which is interoperable with Java. It's kind of this child of Java. So Kotlin's emergence, the official language for the Android app development, has been supported and promoted by Google. So it's actually developed internally and supported by Google as well. And so what happens here is, just like we said, Swift and iOS, you're using all of that for the kind of Mac or Apple ecosystem. The Kotlin language is being used for the Android ecosystem. And so Kotlin offers seamless interoperability with Java. That means if you have an existing substantial code base in Java, maybe you've written a library in Java to do specific things, you can later connect it with Kotlin, and that allows for a smoother transition incorporating Kotlin into the development workflow. So moreover, Kotlin also has concise and expressive syntax, which hopefully makes it easier to learn than just pure Java, and it has an ability to reduce boilerplate code and emphasize simplicity. The code more readable and maintainable, but should also enhance overall productivity by enabling developers to focus on the essential aspects of their applications. So it has a better syntax than Java. That was kind of one of the main issues behind Kotlin. But again, if you're learning Kotlin, it's really because you're trying to develop Android applications. Whether you're developing them for Android phones or Android tablets, Kotlin will be your way to go there. Next slide here. There we go. And so you might be thinking, well, what if I want to work on both Android and iPhone apps at the same time? Is there one way where I can write once in a language and have it work across systems? There is a language and framework for this. So the language and framework kind of pairing is called Dart and Flutter. You'll hear most people refer to just Flutter because that's your main framework that you're using, but technically speaking, the language behind it is called Dart. But if you just Google search or Google search Dart, you'll pretty much land at the same page. And it's actually all developed internally by Google. So Flutter has emerged as a really popular choice for what is known as cross-platform mobile app development. So what that means is when Google was developing this internally, they created Dart and Flutter as a way to open source user interface software development that allows developers to create natively compiled applications for different mobile, web, and desktops using just a single code base. So what does that actually mean? It means you write your code once and you can deploy it across multiple platforms. So you would write your Flutter application and then you could release it to both an Android phone, an iPhone, a website, and then like a Windows application. So the key strengths of Flutter relies in the fact that it has a rapid iteration process, has what's known as a hot reload feature, where if you make a little change in your Flutter code, you don't need to run your simulator. You just do a hot reload and you can see the changes kind of live on your screen as you're developing. And it offers a pretty expressive and flexible user interface framework. So as you can imagine, since it's really built to work as a user interface application across, again, Android, iPhone, websites, etc., a lot of it comes in mind of a design language of how do I make a user interface for my website, my iPhone and application and my Android application to work seamlessly. So furthermore, Flutter delivers native performance across different platforms. So it will try its best to make sure that the apps built with Flutter are going to be fast, responsive, and have a smoother user experience. It does that by using its own graphics engine internally. And again, the main choice here of why you would choose Flutter and technically Dart is that it's an excellent choice for platform mobile app development. So that way you can write your code once and then it works everywhere, maybe with a few adjustments depending on the actual deployment. I should point out though, this does come at a cost. There is no free lunch. I would say Flutter is a little harder to learn because of the fact that it can work everywhere. So it will probably take you a little longer to learn Flutter from scratch than it would to learn like Swift from scratch. But that isn't to say it's impossible to learn. Obviously, there exists Flutter developers, so people have been learning this and using it. Now, what about the front end of languages? So for example, I'm using Google Slides right now. What is this built with and how is this all working? To understand the front end, we have to talk about a couple of languages here. So there's HTML. So HTML is used for web content structuring. It's a standard markup language for creating web pages and web applications. It provides the structure and layout for the content, including things like headings, paragraphs, images, and links. It's one of the fundamental building blocks of how websites actually work. So if you're ever working on trying to build a web application, specifically the front end, and when I say front end, I mean what the user on your website actually sees, you will need to learn HTML. There's kind of no way around this. There's no alternative to learning HTML. You just got to learn it. And that's the actual like content on the web page. And if you want to style that content, for example, giving it different fonts or different colors or different background images, etc., that's where CSS comes in. So CSS stands for cascading style sheets. It's a style language that will help control the look and feel of web content that is in HTML. So by using CSS, designers and developers can create visually appealing and professional looking websites that are going to be able to hopefully effectively communicate your brand's identity and message. So learning CSS is really crucial for creating those responsive and mobile friendly designs. That way you can have a great user experience, whether they're visiting your website in their Safari browser on their iPhone or on Google Chrome on your laptop. So again, CSS is kind of one of those other front-end web development languages that you just have to look if you're going to be a web developer. So there's kind of no alternative here or no option to not learn this. You have to learn HTML to actually understand how the content gets pushed to the user on the website. And then you got to learn CSS. Otherwise, you'll have a really ugly website. And again, it allows for things like fluid layouts, flexible images, media queries to tailor the presentation of the content. And then again, doing things like just shaping the visual identity of the website. Now, HTML and CSS, those are known as things that are relatively static. That is, the user doesn't interact with those languages. It's just kind of shown the content and then styled the content. If you actually want to have a front end that the user can interact with, for example, you can have a form, have the user fill out the form, and then hit enter and grab that information. That's where JavaScript comes into play. So JavaScript is used for dynamic web development. I would say it's another one of those essential components for web development. If you're going to be a web developer, you will need to learn JavaScript. There's lots of different kind of flavors of JavaScript. So you know, like TypeScript is very similar to JavaScript. And these are kind of all offshoots of each other. The main point is you will have to learn JavaScript if you're going to be a web developer. It basically incorporates the idea of client-side and server-side script. So when we say client-side, we mean if a person visits a website, they are the client and they see stuff that they can fill in. For example, they can click on buttons on the website. And then on the server side, this is kind of where JavaScript works its magic. It connects the two. It allows for communication between the client and the server. The server would be maybe on a that you're hosting. So if you visit, facebook.com, what you see on your end is the client, the buttons, the pictures, the text, etc. That's the HTML being styled by CSS. But then when you click on somebody's profile and you need to grab that information from your servers, JavaScript is actually performing a lot of the dynamic connection between, hey, this user requested this profile page. I got to go back to the server and then retrieve that information and push it out. And then within JavaScript, there's a large community, tons of libraries. So you're talking about like Angular, React, Node.js, Vue, there's hundreds, if not thousands of JavaScript libraries, and there's lots of resources and support for developers. The libraries themselves just allow you to do more specific things with JavaScript. In the same way, Python had libraries for things like NumPy and Pandas for data science. JavaScript has its own libraries, things like connecting to particular backends, like a particular database. And then speaking of databases, while this is not sometimes known as a full programming language, there is the SQL or structured query language, and this is mainly for database management. So I would not technically describe SQL as a programming language. It's really more of, hey, I have a database like a PostgreSQL or a Microsoft SQL Server or MySQL, and I need to interact and query with it. So learning SQL itself will allow you to perform tasks such as creating and modifying databases, as well as retrieving and updating data. And proficiency in SQL is highly valued across many industries. Basically, any industry that is working with databases, SQL is a great tool to have. As far as languages go, this one's definitely the easiest to learn because it's not technically a full language. It's just understanding a few commands on how to retrieve information, like list our top 10 users and then sort them by date. Great, quick language to learn. You can probably learn it in just like a few weeks. Again, you're not going to be able to really build applications of SQL, but it will allow you to recall information from a database. So I'll pause it or kind of stop it right there. If you want to learn more about different programming languages that are available, you can check out our websites for more information. You can either check out our kind of homepage at educate360.com or New Horizons for our technical courses that are available if you want training in some of these languages. And I see a few questions. What's the best programming language for video game developers? Yes, you will get the slides after the presentation is finished. As far as programming language for video game developers, that's actually a really interesting question. Most video game developers use a video game engine, and they'll use something like Unity or Unreal Engine. And you typically are programming either in the kind of user interface that those engines provide, along with C++. That's because the languages require, or the video games require very high performance. So C++, very high performant language. So you're typically using that to actually program in video games, but you're often not just doing kind of video games with raw code, so to speak, you're using like a Unity or an Unreal Engine. But those are kind of rendering engines that allow you to like import 3D objects. They're not technically programming languages. I would say though, if you're trying to build a game for the iPad, then like I mentioned, you would use something like Swift. Um, I guess I'll pause here for questions.
Sure,
Uh,
yeah. If there are any
oh,
extra ones you have in the
I
chat.
see. Yeah, I see a question
Yeah.
from David English. Library means an example of ready-to-go clone. So what I mean by library is if you were to download any of the languages I mentioned, like Java or Python, those come with built-in tools. So for example, if I download Python, I have the ability to perform like basic mathematics, like 1 + 1. What I don't have the ability to do with just base Python would be to interact with something like Power BI, for instance. But there are Power BI libraries where people have taken the base Python and written a library that allows them to easily connect base Python through some API calls to Power BI. You would then need to download that library, and then you'd have that functionality. So you can think of it as a bunch of ready-to-go code that people have worked on to help you accomplish something that, in theory, you could have, spent a year working on yourself and programming it in Python, but it's a bunch of ready-to-go code to save you some time. So, connecting to Salesforce or, trying to visualize Excel plots or whatever with Python, you can do that as well.
So it looks like a couple more questions came in.
I was just mentioning Power BI as like a random example. Python is like used everywhere, so I wouldn't say there's any most likely platform to use Python. It's an open source language, so you can just code on it on your local computer and then connect to whatever you're trying to do. So for example, if I wanted to build Microsoft Teams, I would build that. I could build that with Python, right? So that's not really a platform. It's just me creating applications for my computer. How secure is programming in this languages? Do I need something else to protect the code against tampering for introducing? Um, that's a good question. I would say that has less to do with the programming language and just more to do with the way you deploy your applications. There are uh, there are some languages that are technically more secure than others. So Python tends to be more open in terms of like if you have your code and you don't want to share it with anybody, Python's probably not the best choice because it's easier to see your source code versus other languages like Java, it's sometimes harder to see the source code. Um, but more like a philosophy question than one I can truly answer about the programming languages, um, if that makes sense.
Totally makes sense. And it looks like that was our last question, unless we have another one come in. But aside from that, if anybody in our audience needs any more info on this topic, please do not be afraid to visit us at Educate360 or newhorizons.com. And again, if you did miss out on any part of this session, we will be sharing this recording with all of you in an email after the webinar. So thank you all so much for attending today. Oh, I think two more questions came in. You want to get those real quick?
So David, if you're using Power BI, definitely check out Python. That'd probably be the most useful one. The last question was, I'm looking to enter healthcare industry. I've been in e-commerce and retail. Would you recommend learning Python to us? Uh, I would recommend learning SQL first and then learning Python, because likely, regardless of what industry, you're going to have to learn how to interact with databases. So you might as well learn that one first because it's easier. And then Python's a full programming language that you can take more time to learn with analysis. So I would actually say both. Yes,
Excellent.
exactly.
Nice.
Being a full stack developer, a wise choice. Some of these are like more philosophical questions. Yeah, I mean, I know web developers that are very happy with the decision they made, but I mean, is being the president of the United States a wise choice? Like, I don't know. I could say yes and no on that one. So uh, I'm not sure how to answer that sort of question.
I guess you're gonna have to find out, guys. Alrighty. Well, thanks again for everyone joining us today, and thank you so much, Jose, for all your insight. Again, please do not be afraid to visit us at our websites, and if you guys have any more questions, please let us know. But other than that, thanks again for joining us today, and I'll talk to you all soon. Alrighty. Bye, everyone.